So you can click the download option, and once you click the download, try to extract the files, and inside this you will be having the different directories. Let's explore the Mango today. And inside Mango you have the healthy and the diseased leaf. You can just open that and check for the healthy and the diseased leaves. So these are the various healthy leaves which are present inside Mango, and we also have some diseased leaves as well. So the first step, dataset collection is done. So before a machine can learn, it needs examples. So we collect many pictures of healthy and diseased leaf. This collection of images is what we call it as a dataset. Okay. So here you can see it is already organized into two folders, one for healthy and one for diseased. But when you try to do this in real time, you need to collect all the images and see that you are placing it in the different folders. We call that as labeling. So each image must be given a correct name, whether it is healthy or diseased. So we call this as labeling. A labeling is something like a correct answer which you are attaching to every example. So the computer cannot learn properly unless we first tell it what each example is. Okay, we have to tell which is healthy and which is diseased, right? So this is all about what is called a data set and what is called as labeling. With this ideology, let's go to the Google Teachable Machine. Google Teachable Machine is a tool that lets us to build a machine learning model without requiring actual coding over here. So go to the Google and type Teachable Machine. This will direct you to the link teachablemachine.withgoogle.com. I'll also share this link in the description. And Teachable Machine is training. It's like training a classroom for AI. We show the examples and it's going to learn from them. Okay, let's get started. So in the Teachable Machine, we are going to click Get Started. And it gives us three different options of image project, audio project, and the post project. So we are going to work with image project. And in image, we have two different options, one for standard image and another one for embedded image model. So we are going to use the standard image model here. We are not going to embed any of these models into a microcontroller. So let's take up the standard image model right now. And then you have a lot of options here. You can open the project directly from the drive. Like you can save all the dataset in sense all your healthy leaf and the diseased leaf into your drive, and then you can upload it here. You can open directly from the file, or once you have completed the model, you can also download this project as a file so that you can use it for the future reference as well. So here we are going to make two different classes, one for healthy and the one for the diseased. So we are going to create two classes now, healthy plant and disease plant. Let's start to upload it. So we're going to upload it from our files. So I'm going to take Mango. In Mango, I'm going to choose the healthy one. Let's upload all the samples of healthy plant. Similarly, try to upload all the samples for the diseased plant also. It will take a while if you're going to have a lot of images. We call all this as classes. A classes means it's like a category the model should recognize. Similarly, we are going to go to the diseased. And try to upload the diseased plant also. So here we have two classes, or we say two categories, one for healthy and one for disease. So the model needs categories or classes, so it knows what choice it can take later or it can make later. So once you have uploaded the healthy and the diseased plant, then we are going to click train the model. See the beauty of Teachable Machine. It has made the work so easier. When we try to do all these things with the coding, it's a bit difficult. I would not say difficult. It's like a lot of steps. So Teachable Machine has made it so simple. Right. Now, click Train Model. This is a very important step. So training is, as I have told you already, it's a learning process where the computer is going to study the examples and then find the patterns. So for the leaf images, the computer may learn the patterns like color changes or spots or holes, dryness, or might be the shape differences. All these can be considered like a diseased plant leaf. Okay, right. So we're going to click train the model. It's going to prepare the training data. It's going to take a while. So don't switch the tabs. You must leave this tab open in order to train this model. Okay. And in the advanced settings, you can see some options like epoch, batch size, learning rate, under the hood, and reset to defaults. So let's see what each and everything represent. The first one is an epoch. So epoch means one full round through all the training images. That's what we can understand by the word called epoch. Let me give you an example. Let's imagine if you have 200 pictures, the computer studies all 200 once. Okay, so this is one epoch. So if it studies all the 200 pictures 50 times, that is 50 epoch. So here the default setting is 50 epoch. Means it has studied all the pictures 50 times. So epoch is like a revision. The more times the student is going to review the full notebook, what happens? The better we are learning, right? Similarly is how we can remember this terminology, epoch. The second important terminology is batch size. So batch size is like a small group of images shown to the model at one particular time. For example, here the batch size is 16. So 16 in sense, the computer is going to learn from 16 images, update, and then move to the next 16. It's like 16 images it's going to check. Or in simple words, let's consider reading a textbook. Instead of reading the whole textbook at once, the computer is going to study in small packets. Okay, so that's how you can define the word batch size. Next important terminology is learning rate. So learning rate is telling the model how big a step to take when it has to improve itself. For example, if the value is too high, it may learn too wildly. So there are a lot of chances of mistakes. If it is too low, learning becomes very slow. So the common good value is 0.001. So this is basically, it's like telling the model a step to improve itself. Or let's take an example. We need to decide how fast to walk while learning. Is it going to be too fast? If you study too fast or learn too fast, there are chances of tripping. And if it is going to be too slow, you are barely moving, right? So that's how we can compare an example with a learning rate. Okay. Then we have something called under the hood, where we calculate the confusion matrix and the accuracy per class. We will learn more detail about the accuracy confusion matrix in our future sessions. But as of now, accuracy means how often the model is correct. So if the model gets 90 out of 90 out of 100 images, it means the accuracy is 90%. Accuracy tells how many answers the AI got it correct. Then we have the loss per epoch. So loss tells how wrong the model is. High loss means many mistakes. Low loss means better learning. So loss is like an error score. Lower is always better. Then we have something called confusion matrix. So a confusion matrix explanation you can also see over here. But to be very precise, a confusion matrix, it shows what the true answer is and what the model predicted. So it helps us to see whether the model got confused, such as making the diseased leaves for the healthy ones. So this is like a mistake map, and it shows whether AI is really getting confused or not. Fine. So once this is done, we have an option to review. So either you can use the web camera or you can upload the images from the desktop and check whether the output comes under the healthy plant or the diseased plant. So let's take from the file now. So I'm going to choose some random image. Okay. And then in the output, it will be guessing whether it comes under the healthy plant or the diseased plant. Let's try to take up some healthy plant and see whether it is guessing correctly as healthy. So now you can see that it is detecting healthy plant. So when you test an image, the model is giving you a prediction, right? So this prediction is a model answer after looking to your new data. So for example, here the healthy plant is 100% accurate. Sometimes, let's try a different image, not a mango. Might be, let's go for a lemon. Okay, so I'm trying a lemon image and still it is showing that the healthy plant is 100%. So this means that the model thinks the leaf is a healthy plant. Okay, so prediction is AI best guess. Fine. So now we have learned what is a data set, what is all about training, and what's all about exporting what's all about the prediction. Let's move on to export model. So once the model works, we are going to click the export model. In export model, we have a lot of options here. TensorFlow.js, TensorFlow, TensorFlow Lite. You can just go near to this exclamatory symbol and it tells a very brief description of what it represents. So let's go to the TensorFlow.js now. So .js represents JavaScript. So TensorFlow.js is basically a JavaScript library that allows the machine learning models to run in a web browser. So you can imagine this like a tool that it's going to help the trained AI model inside a web page. And you have an option called download here. So click download and then click download my model. Let's go and see what is inside the model. Okay, I'm going to extract this. So inside this, you can see 3 different files: metadata, model, and weights.bin. This metadata is in JSON format, model is also in the JSON format, and weights is in the bin file. Let's start with model. So model.json, it is a structure of the model. So whatever model is running at the back end, in order to deduct whether it is a plant is a diseased or healthy leaf, has a particular structure, right? That's present inside the model. Metadata has all the class names and the extra details. And weights is what the model learned. So these files are like the brain structure, or you can think this like a memory or the labels for the AI. So a teachable machine here, it's going to give you the sample code that can be copied. So it gives the index.html file. So this is the this is a HTML file, and we can use this particular HTML file along with the model and push it in the GitHub. Okay, so that's what we are going to study in our next class.